All right, guys. So today what we're going to be covering is adding and subtracting rational expressions. So just a little review of what we've done so far. Last week we talked about simplifying rational expressions. For example, let's say we had 9x plus 2 over 81x squared minus 4. And when we had to simplify this, we factored this difference of squares to 9x plus 2, 9x minus 2, and this was 9x plus 2. So these two canceled out to give us 1 over 9x plus 2. The second thing that we did last week was we went over multiplying and dividing rational expressions. I don't really need to go over that because we went over many questions. But the main thing, remember, let's say we had something like this. X over 4 over 9 over 5. Remember this? Because you're going to have a couple questions like this today. This means your first rational expression, x over 4. Now, this means divided, obviously, by this fraction, 9 over 5. And then this becomes, this in blue, it's the same exact question as this in red, except this is a lot more simple because it's x over 4 times the reciprocal of 5/9. Okay. On the notes that you should have in front of you right now, I go through a couple steps and I give you some example questions. It's pretty simple. Obviously, when you add fractions, the denominator has to be the same. And if it's not the same, you have to factor your denominator. And then the very last step, I say, apply basic. And I put basic in capitalized letters in your notes. Apply basic addition and subtraction properties with fractions. Meaning, let's say we have 1 over 5 minus 3 over 11 or something like this. Obviously, I mean, this is super basic, but remember, just your denominator is the first number that they both have in common, or if there is no number that they have in common, you can't think of right off the bat, you can just shove these two together, find the product or multiply this. 5 times 11 is 55, because you can just shove these two together, and then you multiply this side by 11 in the top, because 11 over 11 is 1. So technically, you're not changing the value, you're just making it look a little different, but 11 over 11, you're multiplying everything by 1. 1 times 11 is 11, and then 11 times 5 is 55, so then multiply this by 5 to get 11 minus 15 to get negative 4 over 55. Super, yeah, I know, super simple. However, rational expressions, you have to understand how to add and subtract rational expressions. It's the same concept of basic adding and subtracting normal fractions. We're going to apply the same rules, except we're going to have polynomials instead of numbers. I give you 4 example questions. The very first example question that I give you is 7n over n plus 1 plus 8 over n minus 7. Now remember when we just had a couple seconds ago, we just had 11 and 5, and there's no two common, the lowest common multiple was when I multiplied them together to get 55. Same concept for this. N plus 1 and n minus 7. The easiest way is to get a common denominator of shoving them both together, taking the product of these two. So technically, you know how I multiplied 5 times 11? That's what I'm doing with this, except they're polynomials. It's the same exact basic property. So to find a common denominator, it would just be n plus 1 times n minus 7. And then you multiplied n plus 1 times n minus 7 to get this denominator. So whatever you do on the bottom, you have to do on the top. Now conceptually, n minus 7 over n minus 7 is 1. Anything times 1 is itself. So you haven't really done anything with the value of this at all. You just tweaked it a little. Anyways, here's my denominator. Now 7n times n, because you have to distribute this 7 to both. 7n times n is 7n squared. 7n times negative 7 is negative 49n. All right. Now, same with this. I multiplied n minus 7 times n plus 1. So whatever I do on the bottom, I have to do on the top. Look, this is just a value of 1. N plus 1 over n plus 1. For your numerator and denominator is the same. This all revolves around basic, simple concepts of adding and subtracting fractions, except you just have polynomials. This is 1. This is equal to 1, so you can multiply this by 1. You're going to get the same value. It's just tweaked a little. Anyways, 8 times n is a positive 8n. 8 times 1 is a positive 8. And then my very last step is I'm just going to combine these two together. Negative 49, positive 8 is a negative 41n. And then I'm just going to move this 8 over. Here we go. That's it. And then you're just going to leave it. You're just going to leave your answer just like that. And that is called adding and subtracting fractions, rational denominators. Now I'm going to kind of trip you out right now. How do I know that this is correct? Well, look, plug a number in for n. If I plug a 1 in, I think the easiest number to plug in is, let's just do this. Let's just plug in a 0. If I plug in a 0, watch this. And you don't have to do this, but if I plug in a 0 here and a 0, if I plug in a 0 for all this, I'm going to add this to get the exact same answer as if I were to plug a 0 for here, 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 and here and get the exact same answer. Okay. And you don't have to do this if you don't want, but I'm just going to go ahead and do this just to show you I get the exact same answer. This in blue is the same thing as this. Watch. If I plug a 0 in, 7 times 0 is 0. So 0 plus 1 is 1. It's just easier to plug a 0 in because everything cancels out. And 0 minus 7 is negative 7. All right, so what's 0 over 1 plus negative 8, or I'm sorry, 8 over negative 7? Or think of it like this. Think of this as a negative fraction. Anyways, however you want to do it, let's just do this. Let's just minus and keep that a positive. So my denominator is 7. My denominator is 7. Anyways, I'm going to have negative 8 over 7 as an answer. Well, let's see if I get negative 8 over 7 for this. Plug a 0 in for here. 7 times 0 squared is 0. Negative 41 times 0 is 0. 0 plus 1 is 1 times 0 minus 7 is negative 7. And 1 times negative 7 is just negative 7, which gives me a negative fraction. See? It's the exact same. Negative 8 over 7, negative 8 over 7. So that's just a concept of showing you your answer is the same thing as your expanded version. Okay. Let's do another one. The next example question that I give you is 7n over in my n plus 1. Oh, I'm sorry. This is what we did. Sorry. 3 over 8 minus 3 over 3x plus 4. Okay, now once again, you can't subtract these because they're not like terms. I'm not like terms, meaning the common denominators they don't have a common denominator. So, in the example that I just did before, I'm going to shove these two together. So, my denominator is going to be 8 times 3x plus 4. I mean, you could do 24x plus 32. That's fine, but let's just keep it simple. You don't need to go that far. Just keep it simple. So I multiplied this by 3x plus 4. So we're going to multiply the top by 3x plus 4 to give me 9x plus 12. Okay. Now I multiplied this by 4 to give, I'm sorry, not by 4. I multiplied this by 8. Now I'm going to multiply the top by 8. Negative 3 times 8 is negative 24. Now if you notice, this is equal to 1. This is equal to 1. That's why I am able to multiply them together. Anyways, 12 minus 24 is negative 12. This is my answer. And you're just going to leave your answer. Technically, if you wanted to, you can factor out a 3 to get, I mean, if you could factor out a 3 if you wanted to get 3x minus 4 over 8 times 3x plus 4. But you don't have to. You can just leave it just like that. Okay. The next question is a little different. Well, it's a little different if you leave that trinomial in your denominator exactly the same. But what I'm going to do is I'm going to factor x squared minus 7x plus 12. So I'm going to write my first one, x plus 1 over x minus 4 minus, okay, now I'm going to factor. Two numbers that multiply together to get positive 12, add together to get negative 7 is a negative 4 and a negative 3, and then x minus 1. Okay, my common denominator is this. I already have this x minus 4. All I'm missing is an x minus 3. So my common denominator is x minus 4 times x minus 3. All right, what did I do? What did I do to get x minus 4 to look like this? I multiplied this by x minus 3. So I have to multiply the top by x minus 3 also. And then look, it's just distributing. You're going to get x squared. I'm just going to do this quick in my head. X squared 1x minus 3x is negative 2x minus 3. This is this multiplied out. I just did that real quick. This is STEM, so I'm assuming all of you guys are following me with that. All right, minus. Now this is the tricky part. This is where it gets confusing to a lot of people. I don't know, hopefully it won't get confusing for you guys because you're a STEM class, but this is where people mess up. See how this minus sign? Most people would say, well, I didn't do anything from here to here, so I'm going to leave that minus sign and then my numerator stays the same. That's like 99% correct. The difference is, look, this is technically, this minus, think of it like this, is a negative 1 times this. Minus means it changes both of these, so negative x plus 1. Because you have to distribute that negative into both of those terms. Now you can simplify. Negative 2x, negative 1x is going to give me a negative 3x. Negative 1, a negative 3, positive 1 is going to give me a negative 2. There we go. And there's your answer. And just leave it just like that. Okay. The very last question that I give you guys, it's pretty simple, but I'm going to have you guys pause this video and see if you can't figure it out by yourself. Go ahead and give it a shot. Okay, so if you pause this video, you should have seen that your common denominator, I'm going to go ahead and write this out, 4 over 5a plus 7b over 4a squared. Hopefully you guys saw that your common denominator is 20a squared, not cubed. Not cubed. It's your lowest common denominator. You're not just shoving everything together. It's your lowest common denominator. All right. So what did I have to do to get from 5a to 20a squared? I had to multiply this by a 4a. So I had to multiply the top by a 4a to give me 16a. What did I have to multiply 4a squared by to get to 20a squared? 5. So I have to multiply the top by 5. which is going to give me positive 35b. Hopefully you guys are understanding. There is 5 times 4 is 20. That's how I got that denominator. But look, I'm not multiplying a squared times a because I don't need that. I need your lowest amount of a's that I can have equally from both of them. There's 2 a's here. There's 1 a here. So my common denominator would be a squared because I only need 1 extra a to get to a squared. That's why I multiplied it by the a. However, for this a squared was already the same, so I didn't multiply that by a. Anyways, this is your answer right here. There it is. 16a plus 35b over 20a squared. So after this assignment, we are going to be concluding rational expressions on Thursday by solving rational expressions. And it's not too bad, but you have to understand how to you have to understand how to do everything. Simplify, add, subtract, and multiply rational expressions before we can get to solving rational expressions. It gets a little tricky. All right, thanks.